Okay, hi, my name is Giangiacomo Bravo, and I can say I define myself as a computational social scientist, which means that basically I'm using computer-intensive methods, including big data, including social simulation or experiments running on internet apps or whatever, to study and understand problems that has to do with human behavior and social sciences. In particular, I'm interested in environmental issues as a whole, or sustainable development. And, well, I will present something today that is actually quite new for me. It's the first time that I'm working on waste, nuclear waste. I'm more used to work on other kind of environmental issues like resource management, water or consumer behavior, or energy. For instance, I just finished a project with the bioenergy group in Växjö, but that was about district heating, basically. So this is relatively new, something we are starting now. It's exciting, but on the other hand, I don't know too much, to a certain extent, about this new specific topic. Anyway, the problem, as far as I understand, is that we have a project in Sweden which is for a nuclear waste repository. So all the waste produced by the 4 power plants will be grouped and, well, dig down in the ground close to Oskarshamn if the project is not changed. And, well, in a few decades, 40 years or so, all the power plant will be shut down, so no longer any new waste. Everything will be closed, and it's supposed, technically, from an engineering point of view, to last for hundreds of thousands of years. I mean, as long as the nuclear waste remain dangerous, they should be underground. Well, the problem is, okay, nice, but imagine then in a few thousand years, somebody starts digging that. I mean, there will be no sign, no longer, you cannot assume there will be anything marking this place in a few thousand years. So a crazy archaeologist of the future may just discover and said, wow, there is something here, just start digging. That's not a good idea. So what basically we have is a problem of long-term management of information. How can we transmit information that there is something underground and has certain characteristics? Then it will be up to our descendants to decide whether to dig or not. Maybe this will be a resource for them, or maybe it will just be dangerous, so it's much better to leave them underground, or whatever. But the point is that if you take a long-term perspective, and by long terms right now, I said at least some thousands of years, you can basically take nothing for granted. I mean, you cannot take for granted that they will understand our language, that we understand our sign, but you cannot even take for granted that there will be any archives left of what we did, or that if there will be any state or institution able to enforce, well, the no pass area or whatever. So the point is that, given that we don't know the future, how can we explore what can happen? And the idea of exploring what can happen is what can we do now in order to at least increase the probability that our descendants will understand the problem. We cannot do experiments on the future because the future is not there yet, and it won't be there for many, many years. But we can do experiments using virtual environments where there are real people interacting in some simulation and interacting among them, and having a problem that has some similarity with the problem at hand, which is transmitting information and understanding information without too much losing in that, and then try to understand what we can do in order to improve the final outcome. To me, that's maybe not best, that's the best we can do, maybe not enough, I don't know, but still, that's something that I think is worth trying. So basically, our plans is to develop serious game environment in order to explore this, well, challenging issue, I should say. For this, we have a group that is really interdisciplinary. Most of us are part of the DISA Center, but we also have some people from archaeology, we have people from media communication, we have a nuclear waste consultant, and so on. So it's kind of broader group. And right now, our work plan is basically the year to come. We already have some funds coming from basically from the university, and we will start doing the work in two directions. One is to define the basic concept we need and the basic task we need to develop in order to implement this serious game environment, and possibly start testing them a little bit in a kind of possibly with students or in relatively simple case as a kind of proof of concept on the one hand. On the other hand, we need to identify the external partners. Actually, we already have a couple of them. In particular, we already have on board the Swedish Authority for Nuclear Waste and the municipality of Oskarshamn, which are possibly the two ones that are most interested in this, but not necessarily the only one. And we need, of course, to prepare for the next step, which basically needs to get funding, apply and get funding for a longer-term project, because this cannot be something that is solved in 6 months or 1 year. We have a perspective of having 4 years project at least. And of course, within this project, the real work will be done, both in terms of conceptual development, but especially in terms of building and testing the environment first, and then the deployment into the real world. I mean, it's a virtual environment that has to be deployed in the real world of players, of people doing it. And of course, then data analysis and reporting. And all this has several challenges, starting from who should we work with? Also, and especially to a certain extent, from the technical side. Of course, we have people from the media communication, from the media technology department in our team, but a crucial task, for instance, is to, well, have the players. I mean, you cannot assume that the moment you have a gaming app, there will be people playing it. There is so much competition that, for instance, a good partner could be a developer of computer game or apps for gaming that already has a pool of players, and we can use it. That's just an example. Of course, there are some more scientific elements to do, developing what we need. We basically are in a situation where we need to understand the form of cultural evolution or institutional evolution, and to a certain extent try to predict it, which is a gigantic task. Probably beyond what we can really do, but at least having a glimpse of what can do and or what can happen and what we can do in order to, well, create some scenarios that are possibly better than others. And then, of course, all the technical parts. Sorry, I will skip a little bit. Unfortunately, Marcel is no longer here, but Aris? Is sorry, the people from media technology that will be more in charge. Thank you. Of this are no longer here, but still, there are a lot of challenges from the technical side that I don't really catch in fully, but still, I assume they are there. And they are also challenging from the, well, analytical side, because then, assuming that everything works well, we will have a constant flow of data, unstructured, that we'll need to distill into something meaningful, and this may have something to do with the visualization, or that we were just discussed, or maybe with statistical techniques that are closer to what I know about, and so on. And finally, moving from the scientific level, from the data, from the analysis of the data, to practical advices. So our partners will, at the end of the day, know what they should do in order to improve the chances that the message will get right in the future. Because if not, that will be the risk. If you remember, the Alien film just started because a message that was stay away was, well, actually misunderstood as a come here and help me message. That's exactly what we don't want to happen. So thank you very much.
So this is maybe out of scope for today, but I'm curious on how you expect to evaluate this and how you expect to actually give some credence to your findings if we assume that people from 1,000 or 2,000 years into the future Because if we look back into history, the best way would probably be to just write it down, the instructions in all known languages. We've seen that work with the Rosetta Stone, for example. How will you check if something is better than that?
I mean, technically, how we will validate our model.
Yes, but how will you do that?
Yeah, I mean, there is no way to validate the model as a whole, but there is the possibility to validate specific mechanisms that you find are relevant.
Such as?
Such as mechanism of transmission of information, possibly, and that's my real hope, because that would be the scientifically most important thing for me, mechanism of evolution of part of the culture, of a very specific part of the culture. So understanding how concepts, for instance, change over time, or similar things. But that will be challenging, okay? To me, it's a total new world to explore, to be honest. And to a certain extent, I'm interested in this project because of this, because my scientific interests are environmental issues now, okay? Not in several thousand years ahead. But on the other hand, it's so challenging, and it's so interesting from a strictly social sciences point of view, this project, that I think it's worth trying it. I cannot grant anybody that we will, at the end of the day, we will have something that will be usable, of course. But that's research.
Well, is it really? I mean, I don't get how you can evaluate it, and then it's not research.
As I said, I cannot evaluate the whole system. I can evaluate the moment I see a mechanism that I imagine it works. I can run an experiment with real people in a reasonable time in a virtual environment to check whether this transmission mechanism of information works.
But these people
because I can make a prediction from the mechanism, and I can check whether this prediction is realized in the virtual environment.
But I mean, these people, if you would write it in English, they would understand it. So they are grounded in here and now. So people 1,000 years from now might be different. How will you be safe against that?
The basic assumption is that there will be human beings, okay? If there are some aliens coming, I don't speak about. But human beings are human beings. There are cultural differences, but there are also some specific patterns of behaviors that are constant across time and across space. And these are the ones we should exploit, I think. Of course, I mean, not talking really about aliens coming in Earth and start digging, because that's really, really science fiction at this point. But I'm talking about human beings. So still, there are something keeping us all together. And we are shared. I mean, there is cross-cultural, for instance, research showing how much of our behavior is constant, despite different way of eating, wearing, behaving, or whatever. But still, the bulk of being human doesn't change over time. And possibly it's the same we have now that we had thousands of years ago when we were hunters and gatherers. And basic behavioral patterns actually derive from the time we were hunters and gatherers, which may also be problematic today. I mean, the problem of diabetes and the problem that we are eating too much sugar is because we are coming from an era of starvation. So each time we have a sugar, it's really hard to, well, resist.
Okay, thank you very much. We'll need to finish now. Thank you.
Yeah, thank you.
We will take just a very short break, so 5 minutes. So please come back at 2 o'clock. Thank you.